Everyone, good morning, namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, April 25, 2022, Monday 3:29 AM. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ. आज तारीख 25 अप्रैल 2022 सोमवार 3:30. Back here with title, same title as usual. Title is very serious, and that is Real Quality Requirement, Coordination Engineering only. Way, projects, works, designs, contracts, reliable engineers, power of and that is where we have to confer with, we have to discuss. It's important for everybody, everyone that what we discuss should be clearly visible. This is my Suraj_engineer at yahoo.co.uk email ID. I repeat, Suraj SURAJ underscore ENGINEER at yahoo.co.uk. Civil Engineering Division I belong to, and I am Civil Engineer, Arbitration Engineer, International Professional and Chartered Engineer. That's what I am for your information. And of course there's another certification, and that is Arbitration Engineer Certification. Arbitration Engineer Certification, that's here, you can say, let's highlight. And that's here says Arbitration Engineer Certification, and there is then International Professional Engineer India, Chartered Engineer India. I close this file, Chartered Engineer India, and International Professional Engineer and Arbitration Certificate. I close it. So many files means cause problems. And this is my quality file. Bharat India speaks about real quality and real coordination. And of course, coordination engineering, which is very much important for everybody. Quality, real quality, and real coordination. These are issues that we have to confront with every day, and this is long-term plan to interact with people about quality and coordination. It has been witnessed, it has been experienced that quality, or you can say state of quality in our country, Bharat, India, is too low in its character. Actually speaking, it doesn't exist. This means it should be at least 100% compliant, but it's not even 50% compliant, unfortunately. Experience says that quality is very important issue. It should be considered, but does it happen? That's point is. That's what point is. Does it happen? But it doesn't happen. But I think quality is very important issue. Coordination is very important issue about which we cannot live properly. People have to understand what is quality. Quality is not a joke. It's a requirement. And if we don't value this, means we don't value ourselves. We don't value our future. We don't value our work. We don't value then we cannot sell ourselves, our products. If our products are not sold, means we don't have money, we don't have value, we don't have society, we don't have future. Economically, I'm talking about. Quality should be in competition actually. It is not even existing. How can it be in competition? Coordination and quality both are very important. I didn't find any place till now where I can say I can claim quality access here. It should be everywhere. It should be in manufacturing, it should be in production, it should be in processing, it should be in construction, it should be in designs of every product, and it should be in society, it should be in individual character, it should be in government, it should be in corporate world, it should be in parliament, it should be in legislature and judiciary. You may say there should be no place where quality should not exist. I'm expanding this because everywhere there should be quality, and if you miss even at one place, it impacts on other places. I am Bharatvasi, I am Indian, and that's why I'm very much concerned. Quality of governance, quality of executive, quality of legislature, and quality of people on top of all. If public fails to understand what does quality mean, this means public sleeps. Public cannot take it easily, but public is taking it easily. Public takes it easily. People are not serious. It is unfortunate that we people are not serious. And our being non-serious means bad quality wins. Bad quality wins, that's what I say. But why should bad quality win? Because we allow bad quality to win. Why do we sleep include engineers also? We and if engineers are not serious, nothing is possible. Engineering is not in work alone on site. It is in designs, it is in planning, it is in quality, it is in safety, it is in service, it is everywhere. Engineering world exists everywhere, and it is engineer unit of society who has to give, who has to deliver quality. And if engineer cannot do it, no one else can do it. Quality doesn't mean what I say you do. Quality means a system exists and that system requires this. When I say system doesn't mean, it doesn't mean quality system. This means system of living. How one individual lives, how one individual's family lives, and how does our society live. And then we can say how does our nation live. That is one question which we have not answered yet. People are very efficient in making compromises for what they themselves do not know. They forget that they are paying taxes. All time they pay taxes. Whatever works are done because of contribution taxes. It may be in private sector, it may be in government sector, whatever money is used, ultimately, directly or indirectly, it is public money, people's fund. It may be by contribution or it may be by whatever means, whatever work is done in country that belongs to people of this country. But people do not think that way. And engineers is one person. Engineering community is one, you can say only one, exclusive one, who can change entire scenario, because generally and specifically engineers are called agents of change. Engineer is called agent of change. But if engineer does that, it's good. If engineer does not do that, it's fault of engineer, because engineer can change. But engineer does not change means there is no engineer, I can say. Engineer means you should have educational background, educational academics, and you should have practical experience both in whatever field you work. And that combination of academics plus practical experience makes one engineer. Experienced engineer who has got every capacity to change entire scenario. And if that cannot be changed, then one cannot call itself engineer. Reason being, engineer changes deserts to cities, deserts to towns. Engineer changes, there is no electricity, but engineer makes electrified city, computerized city. We have to keep in mind that God itself is number one engineer in the entire universe or universes. God is number one. Masters and masters and masters of engineering. There is no end, and because of that blessings, one can become engineer after conducting a lot of study. But if engineer does not utilize that value of education, that power of education, or knowledge. That is number one point. Why we skip that one? That is very important point, and we have to consider that point of view, because engineering is engineering. Engineering means change of society, change of development, change of standards of living, change of economical standard, change of mindset. Change of mindset, that is very important point. If mind is changed, entire philosophy, entire thinking world changes. We can think of better and better, to improve better, to lead to somewhere else. And that's where we can say change is important, and engineer can be called a changer. Social change, environment change, economic change, political change, governance change, every change, directly or indirectly, it is linked to engineers, because every politician claims or programs for development, for this and for that, and that come only through profession of engineering and profession of medical sciences, because health should be kept number one, and in parallel to that, development should be kept number two, or you can say in other words, parallel to health. Those who can do that, that country moves forward. Engineers have to think of that way, these domains, and that's when I say quality engineering. If your life is quality oriented, it should be important that it is oriented. You should make sure, everybody should make sure that I can live quality of life. I don't say quality of life means additional facilities. No, I am not stating that. I am not going to say if you have car you have quality of life, if you have helicopter you have quality of life. Not at all. Because that is luxury and everybody cannot afford luxury, but quality does not include luxury. Quality includes basics of life. Quality includes good education, quality includes good food, quality includes good shelter, quality includes good conduct, quality includes good efficiency, and quality includes good thinking, honest, sincere work. Quality does not mean that you should have economical status. Educated person can do much better than those who are riches, because educated persons are not avaricious. When engineer joins, or can say engineering student joins university or institution, at that time probably that student has got certain ambition in life, that I would do this for people or world. But where does that ambition break on way to becoming engineer? I do not know where that ambition goes away, and everybody starts compromising of situation. And that is drawback of society, that when we adopt ourselves to change our system, we forget change and forget system, and we start thinking of ourselves that I must survive by whatever way, and I least bother about whatever is required. I just say that my service should go on, my job should go on, I least bother about society, and then I forget everything. That should not happen. Quality means certain sets in life, certain definitions in life. Mind should be positive, thinking should be positive. There should be no depression in mind. When you are an engineer, you have a lot of responsibility in your job itself. Whatever level of engineer you are, doesn't matter. Work is accurate, it should be accurate. We cannot work as mindless people. If we work as mindless people, then we are not engineers, because engineering means mind. Engineer itself, the term itself, engineer itself means it is ingenuity, it is genius status of a person, that is called engineer. And that's what I say, real quality of engineering comes when one is having certain status of quality. First requirement is engineer should be quality oriented, of course quantity oriented as well, because quality standard achievement in given or distributed or delivered quantity is real engineering. That is real production. If I don't maintain construction quality, I don't maintain production quality, I cannot call myself engineer, and I can call only useless person because I waste natural materials. Decision of quality stands with us. We have to decide ourselves to what level of quality we are going to achieve, and that's in hands of. Means we have to keep in mind cost factor, we have to keep in mind time factor, we have to keep in mind reliability factor. Whatever we produce should be reliable, and that reliable, many times I explained to you, it's a stand of safety, it's a stand of service, it's a stand of, you can say, durability, and it stands of everything else that can be covered within that definition. So we can say quality is something very, very different. Don't mix it with systems, or don't mix it with what you say property of material. It should be overall. Controls of quality plus quality commands plus quality trust plus quality reliability. Everything must be concluded, must be included in given system, and that system is already available, and that is drawn and designed by practicing engineers or experienced engineers or whoever are involved. Those systems are based on facts of life. We cannot simply ignore all these, and that's where we say coordinated approach to all quality is a must. You can simply say coordinated approach should move towards destination of defined quality or required quality, and that is where importance lies in. It may be designs world, it may be manufacturing world, it may be construction world, it may be whatever world we say, quality has to be considered in its direct approach without any, we can say without any, you can say without any negative point or without any slackening. It is very important, or else we stand nowhere. And that's what I say. It's not that I'm defining this, you know it very well. I'm just trying to refresh and tell you that it is done, you are forgetting, please don't forget. Fixation of quality, real quality is very important in every country, and we are not remote from others. If we don't keep quality, people would know we are not quality nation, and there can be given no excuse that we could not do it. This is reason. No reason plays role. Quality is not produced, I don't know why it's happening. Despite we have millions of engineers in our country, quality is not coming out, and particularly in production and manufacturing, it's happening. It may be civil construction, it may be EME construction, it may be digital construction, or it may be whatever. The manufacturing of steel, manufacturing of other items, you may say manufacturing of other products, there can be no guarantee given to quality. What's happening, how's happening, why we are not serious, these questions are demanding answers. These questions have been demanding answers. We are not answering these questions, and that is where we fail. And I simply say no excuse for whatever concession demanded. There can be no excuse that can be accepted, because quality is a requirement, and quality requirement cannot be compromised. We can't compromise anything just in the name of certain documents we have. We cannot say, see, we have got quality certification and you should accept what I'm saying, what I'm giving you. That is not acceptable, because I have to be sure with confirmation that product is quality one. And if I am not sure, I don't care for your system, because systems are only systems. Systems don't have living entity. Systems are just referrals. And what we are talking of, living entity in production, in manufacturing. When people are care are formations, then there are formations of various lines which may be called red lines. Red lines means something missing or something being done wrong. We have to do it right. And that's what we say, something should be like that. Every day I say, and we have to see, can we know and apply product and works quality standards complied with international standards, or at least our own standards. When we say international standards, this is nothing very extraordinary. Everything is internationalized in this world. We consume products of other countries, and other countries might have consumed our product. This could happen. People move from one place to another place and then to another place, and same way commodities move, and same way, I worked in many countries because of that reason, a moment. Of course, it is economical relation. Of course, you can say it is some other relation. We have to move on. We have to move forward. Then what question is questions? Can we work on required coordination, bearing activities to achieve defined or expected quality profile on work? That's the point. Where do we fail? And if we fail, why do we fail? Why don't we control ourselves? What comes on way that we cannot control ourselves? What way defines that we don't have any level of determination towards quality goal? And if we don't have any determination level, we must not be having any coordination level, anything. And informations keep missing, and we do not worry about that also. We go on doing, okay, let it go this time, next time we will see. And that next time never come in. Why we should not revisit ourselves? Why we should not revisit our specifications, our works, our designs, our methods, and update world working standards requirement are there, but can we do that? Can we understand that? That's an important point. Why should we not apply work relational coordination requirements? Why? Question again comes, why? Why should we not apply work relational coordination requirement? Do you think it's not a must? Is it not requirement? Is not reliable solution? We have certainly worsening state of quality of works, and how to improve such mandated works quality to certain minimum required marks, at least to match with minimum international requirements, or whatever requirements we agree for. We have to force ourselves, should we not? We have to force ourselves to work on coordination in each activity. Is it wrong? Answer yourself. Why it is wrong? Why it should not be done? Worsening state of quality of concrete and why don't we do that? Concrete is very important component in construction work, because concrete is very important everywhere. Without concrete, no project can be successful, no project can be delivered. That is quality, concrete quality, you may say. And when we say concrete itself, this means strong material, artificial stone, you may call it. Concrete component in construction amounts to major part or major percentage of cost, and reason being it becomes incumbent on us to care about quality of such component. Why don't we care about it? Understanding says we have to be very serious in this regard, and we should not avoid its importance. Worsening state means worsening state of communication, worsening state of coordination. Both jointly lead to worsening state of quality achievement. That is very significant point. We have to make ourselves available to think and to consider. That point we have to be very serious about. Why not to be serious about that point? Worsening state of communication and coordination during working for engineering designs and executions or construction activities. Determined and dedicated role of engineers towards realizing these requirements, or else quality remains a myth and not a fact, not a realization milestone. Can we do it? Or we are incompetent and inconsistent societies and communities in engineering? We have to think of all, are we engineering force or incapable lot? That is also we have to decide. Shall we? Shall we? Shall we do what we say? My point of view is, shall we do what we say? Or we are sleeping partners? Can we do? Or we are incompetent, inconsistent societies and communities in engineering? Are we engineering force or incapable lot? When shall we awaken ourselves? Shall we transform existing engineering strength into standard quality working force? Who shall decide about all such questions that are being faced by current deliberations must? Every time we can discuss this, there should be no deficiency. There should be no slack, because deliberation should be continuous. As you know, technologies keep changing, working practices keep changing, and we can say speeds keep changing, but basics are same. You have to keep that. Information must be brought to those personnel who require it. It must be provided at right time for right requirement, and quite rightly duly coordinated. Without coordination, information has got no meaning. It can be an error, or it can cause error on works. And errors are sometimes very expensive, time consuming, and these should be avoided until we do not understand that this is an error. Dissemination of engineering information about quality requirement, about coordination requirement, and this dissemination must be clear clear, and concept should be clear, requirement should be clear, its methodology should be clear, dissemination of engineering information about quality requirements and how to transform using method statements. When I say method statement, it is a big subject. Generally, even engineers do not understand meaning, or you can say impact, that method statements can pass on to quality system. Method statements are not simple statements. These are very much technical and practical statements. These are actual one. What in fact is going to be worked upon, that should be included clearly in method statements. It's not a document that somebody else writes just for purpose of writing or reading. Method statement can be considered a document that tells us what we have to do, what should be sequence of work, what real materials we have to use, what are reference point that we have to consider with, and what is best procedure that can be followed on works. And particularly it applies to construction world. It applies to a world of where amounts are spent on natural materials to do correct work, right work, service of that item we produce, safety of that item we produce, and you can say long-term distance or durability of that item we produce depends on, was method statement admissible, was it reliable, or it was just a statement for sake of statement. I'm not talking of that situation. How to concentrate on construction methods, decision making, that is another point. Means method statement writing, method statement construction is also a technique, a specialty, an expertise that only everybody cannot have. Only those who have the job, they can do it. How to concentrate on decision making and how to have a resolution or to do right work per specified requirements. Methods can be designed and drawn, stated for design certification. Coordination is very important for reliable methods, for reliable coordination I'm calling, because if coordination is not reliable, then it has no meaning if there is just no coordination. Same thing. We have to be very clear about that also. If we know what we have to do, or else we miss time, we miss everything. I'm going to talk to you about concrete specification as usual, because ultimately that is our aim. Concrete is a world material, it's used everywhere, and by chance I am just referring to Japan concrete specifications only. For reference purpose, I will take Qatar specifications also. Whatever the document we can achieve, we can get it. We have to understand, we have to analyze our documents. We have to see what we can do, how can we do it in a better way, and that's we talked of this high purity concrete. We talked of this system yesterday, tension softening curve, and we talked of high purity concrete, and also we talked of, you can say, passability of for narrowed area, absolute volume dry rod coarse aggregate, and we talked of pre-packed concrete. We talked of minimum size of coarse aggregate, coarse concrete product, moist curing, temperature control curing, accelerated curing, and steam curing. We talked of centrifugal compaction, and we talked of casting and hard concrete. Hard concrete, that we talked of casting, we will talk about here, and that says expensive concrete. And just have a little revision of 2 or 3 points here. What it says, hard concrete of a temperature of 40 to 60 degrees Celsius is used to place in formwork. It will remove form in a short time after hard curing, that is called hard concrete. Its temperature range of concrete 40 to 60 degrees Celsius, used to place in a formwork and remove form in a short time after hard curing. Casting in production of concrete products, the concrete process of placing concrete into a formwork and then providing compaction to placed concrete is called casting, while stripping formworks is called demolding. Casting and demolding. Again I say what is casting. Production of concrete, process of placing concrete into formwork and providing compaction to that placed concrete is called casting, and while we remove form or strip form is called demolding. Means placing of concrete products of hollow cylinders such as poles, piles, pipes, and so on. Effect of centrifugal compaction is related to magnitude of force originated by revolution of formwork. Acceleration of centrifuge usually adopted is 20 to 40 degrees, 20 to 40 G. And then we have steam curing. Steam curing is usually conducted at higher temperature than 35 degrees Celsius. Steam curing is usually conducted at higher temperature than 35 degrees Celsius. Such curing is that to maintain temperature of concrete at a lower level, lower temperature, lower than 35 degrees Celsius is not included here, usually higher than 35 degrees. Accelerated curing, some curing methods to accelerate hardening state of concrete, such as steam curing, autoclave curing, hot water curing, electrical curing, infrared curing, and high frequency curing. However, in general, steam curing is widely used. Temperature control curing. This curing method is to control temperature in each part of concrete to facilitate normal hardening process and to avoid cracking after hardening. That is temperature control curing. That is method is to control temperature in each part of curing, each part of concrete to facilitate normal hardening process and avoid cracking after hardening, as well as development of excessive internal stress. In utilizing this curing method, it is necessary to take into account both size of members and effect of construction condition. Then we have moist curing. You know it very well. Ensure necessary amount of water for hydration of cement in concrete, since it is not sufficient just by preventing evaporation of water from placed concrete. This curing method is also effective in preventing cracking due to drying shrinkage during concrete products. Very complex actually. It's not that as we think so. Concrete product, some example of concrete products are beam pipes, piles, beam pipes, piles, you may say blocks, railroad sleepers, shield as segments, and precast composite slabs. They are mass produced in succession in factories for different applications. Concrete members produced in factories are usually called factory product, precast product, concrete product, cement product, or fabricated product. In this specific chapter, that is chapter 2, expensive concrete. What is expensive concrete? We have to understand essential matters particularly required for achieving qualities and performances of expensive concrete. Expensive concretes referred to in this chapter are shrinkage, compensating concrete, and is general term for a type of concrete which consists of expensive admixture mixed together with cement, water, fine aggregate, coarse aggregate, and other admixtures, and which causes volume expansion, even after step of hardening. There are various types of expensive concrete and different qualities depending on materials and mix proportions. In case when expensive concretes are classified based on expensive extent, roughly divided into shrinkage compensating concrete and concrete for chemical pre-stressing. And when reinforced concrete using expensive concretes are functionally classified. These are roughly divided into shrinkage compensated concrete and chemically pre-stressed concrete. Shrinkage compensated concrete and chemically pre-stressed concrete. By restraining expansion of concrete, by restraining expansion of expensive concrete with objects such as reinforcing bars, compressive chemical pre-stress shall be induced in concrete, while objects of tensile chemical pre-strain shall be induced. So by restraining expansion of expensive concrete with objects such as reinforcing bars, compressive chemical pre-stress shall be induced in concrete, while in objects tensile chemical pre-strain be induced. Shrinkage compensated concrete is reinforced concrete imparted with small chemical pre-stress at such a level to offset or reduce tensile stress occurring due to drying, shrinkage, or other causes. Chemically pre-stressed concrete is reinforced concrete imparted with a large chemical pre-stress by addition of large amount of expensive admixture compared with that in shrinkage compensated concrete, so that chemical pre-stress remains even when drying shrinkage has been offset. It is possible to demonstrate effectiveness of chemical pre-stress and chemical pre-strain in design of members and structures by utilizing chemically pre-stressed concrete. Even when expensive concrete having same expensive property is used for reinforced concrete, it is possible to functionally classify that concrete as either shrinkage compensated one or chemically pre-stressed concrete, depending on degree of restraint induced by objects such as reinforcing bars. Therefore, expensive concretes are roughly divided into shrinkage compensated or shrinkage compensating concrete and chemical pre-stressing concrete based on expensive capacity, which is totally different from classification based on function. In chemical pre-stressing concrete, strength loss due to expensive action shall not occur. If proper restraining objects are provided, if provisions of restraining objects is improper, strength loss shall occur. In contrast, for shrinkage compensating concrete, expensive admixture is used in such an amount that obtained concrete strength is almost equal to that of concrete with same water binder ratio and without expensive admixture in mixed proportion. Expensive concrete mortar has been applied mainly as cast in situ, cast in place concrete using shrinkage compensating concrete products using shrinkage compensating concrete or chemical pre-stressing concrete, various fill concrete and mortar for filling voids in inverse lining or below bridge bearing. Chemical pre-stressing concrete is also used for cast in place concrete. Classified of expensive concrete, shrinkage compensating concrete goes to shrinkage compensating concrete, and then chemical pre-stressing concrete goes to chemically pre-stressing concrete. And these are linked also. Chemical pre-stressing concrete goes to shrinkage compensating concrete, and shrinkage compensating concrete goes to chemically pre-stressed concrete. When using expensive concrete materials, mixed proportions, production methods, quality system methods, quality management methods, and construction methods be determined so as to produce designated quality. Expensivity of expensive concrete varies according to type of expensive admixture or cement used. Amount of expensive admixture per unit volume of concrete, age, methods of curing, environment of structure, and dimensions of member cross section. Performance requirements for expensive concrete vary according to whether shrinkage compensating or chemical pre-stressing concrete is used. Materials, mixed proportions, production method, and quality management method of system should therefore be determined so as to produce designated expensivity. When applying expensive concrete, it should be organized in phases of mixed proportions, design, producing, production, and construction under guidance of professional engineers who understand characteristics of concrete and learned to use techniques and have adequate knowledge and experience. Quality of expensive concrete. Expensive concrete shall meet performance requirements in terms of workability, strength, expensivity, durability, water tightness, and steel protection. Variations of quality shall be minimized. Expensive concrete as well as ordinary concrete should have designated workability and expensivity with minimum variations. Variations of expensivity may prevent shrinkage compensation or application of chemical pre-stress from producing an intended effect or lead to strength reduction due to excessive expansion. Quality of expensive concrete should therefore be fully managed. Expensivity of concrete, that is expensive concrete, be expressed in rate of expansion obtained in accordance with specs. Test value of an age of 7 days shown in attachment should be used as standard value. Standard range of expansion coefficient of expensive concrete is shown. expansion ratio of shrinkage compensating expansion range of shrinkage compensating concrete, that is between 150 into 10 to the power minus 6 and 250 into 10 to the power minus 6. This expansion ratio of shrinkage compensating concrete. Expansion ratio of chemical pre-stress concrete, that is between 200 into 10 to the power minus 6 and 700 into 10 to the power minus 7. For chemical pre-stressing concrete, between, we have seen that. Then for chemical pre-stressing concrete used for concrete products, upper limit of expansion coefficient may be set out 1000 into 10 to the power minus 6. Coefficient of expansion of expensive concrete varies accordingly not only to concrete mix proportions, curing methods and age, but also to test conditions such as dimensions of specimen and restraining condition. Coefficient of expansion of expensive concrete shall therefore be expressed in rate of uniaxially restrained expansion or coefficient, you can say, of expansion of expensive concrete varies according not only to concrete mix proportions, curing method and age, but also to test conditions such as dimensions of specimen and restraining conditions. Coefficient of expansion of expensive concrete should therefore be expressed in rate of uniaxially restrained expansion obtained in accordance with attachment. Restrained expansion of expensive concrete, restrained expansion of expensive concrete and shrinkage, expensive additive for concrete. In method, specimens are used that have a rate of uniaxially restrained reinforcement of 0.95%. In method, specimens are used that have a rate of uniaxially restrained reinforcement of 0.94%. Provide, that is, restrained reinforcement uniaxially. In method, specimens are used that have a rate of uniaxially may say restrained reinforcement of 0.95% provided by using restraining mixtures, namely restraining and plate, and restraining bars, restraining and plate and restraining bars, pre-stressing steel. It should be noted that reinforcement rate is lower and expansion rate is higher in ordinary concrete than when this method is employed, even where same expensive concrete is used. Rate of expansion and velocity of expansion vary according to type of expensive admixture. Quantity of expensive admixture per unit volume of concrete, curing temperature and degree of wetting and drying. If a test is conducted in accordance with attachment method for testing and expansion of expensive admixtures by mortar, expansion is completed at age of 7 days. Rate of expansion is therefore expressed in uniaxially restrained expansion joint rate at an age of 7 days. Also in if test is conducted in accordance with H-Wind method for testing and expansion of expensive admixtures by mortar, expansion is completed at an age of 7 days. Rate of expansion is therefore expressed in uniaxially restrained expansion rate at an age of 7 days. Also in testing of expansion by concrete as a standard practice. Expensive concrete is roughly classified by major use into shrinkage compensating concrete or chemical pre-stress concrete. Standard range of expansion rate is shown for each type of concrete. Range of expansion is same for shrinkage compensating concrete and chemical pre-stressing concrete in range between 200 into 10 to the power minus 6 and 250 into 10 to the power minus 6. User may select an appropriate type considering use of expensive concrete. When applying an expensive admixture to shrinkage compensating concrete with a water pointer ratio of 30% or lower, such as high strength concrete and high fluidity concrete, expansion may be controlled at an early age because of lack of water required for hydration of expensive concrete. When using an expensive admixture for concrete with a low water binder ratio, it is necessary to verify in advance type and quantity per unit volume of concrete of expensive admixture, curing method and age at which expensivity should be determined by testing in order to prevent abnormal expansion. In chemical pre-stressing concrete, inappropriate arrangement of reinforcing bars or steel pipes for restraining expansion not only presents development of effective chemical pre-stress but also deteriorates quality of expensive concrete. What it does? Says in chemical pre-stressing concrete, inappropriate arrangement of reinforcing bars or steel pipes for restraining expansion. In chemical pre-stressing concrete, inappropriate arrangement of reinforcing bars or steel pipes for restraining expansion not only prevents development of effective chemical process pre-stress but also deteriorates quality of expensive concrete. Area and arrangement of reinforcing bars when using chemical pre-stressing concrete should be determined considering expensivity of concrete, type of structure, characteristics of loads, dimensions of members and construction method. Highly unbalanced arrangements of reinforcing bars. Highly unbalanced arrangement of reinforcing bars in a cross section creates sections with extremely high expansivity where concrete quality is deteriorated. Full attention should therefore be paid to area and arrangement of reinforcing bars. In ordinary reinforced concrete structures, Area and arrangement of reinforcing bars should be determined so that maximum expensivity of concrete, maximum expensivity in members, cross section may be held to approximately 1000 into 10 to the power minus 6 or less during and at compensation of construction. It says that, let's see back in ordinary reinforced concrete. For ordinary, it says full attention should be paid to area and arrangement of reinforcing bars in ordinary reinforced concrete structures. Area and arrangement of reinforcing bars should be determined so that maximum expensivity in members cross section may be held to approximately 1000 into 6 or less during and completion of construction. Possibility that reinforcement yields or fractures exhibiting brittle failure. Possibility that reinforced yield or fracture, you can say cracks, failure even at strain of reinforcement of approximately 700 into 10 to the power minus 6. Tension reinforcement ratio in members of rectangular cross section should be set to 0.25% or higher. In case of T-shaped cross section, longitudinal reinforcement should be arranged in 0.35% or more effective cross sectional area. Let us repeat, because it's important. You can see in ordinary reinforced concrete structures, area and arrangement of reinforcing bars should be determined so that maximum expensivity in member cross section may be held to approximately 1000 into 10 to the power minus 6. That's the expensivity. 1000 into 10 to the power minus 6, or you can say 1000 divided by 6 zeros, you can say 1 over 10 to the power minus 3, so or less during and at completion of construction. Possibility that reinforcement yields of fractures. And we have to see this point, possibility that reinforcement yields of fractures exhibiting brittle failure when flexural cracks occur due to increase of movement that induces flexural cracks owing to chemical process. Viscous is greater than ordinary reinforced concrete. In order to prevent brittle failure even at strain of reinforcement of approximately 700 into 10 to the power minus 6, tension reinforcement ratio in rod members of rectangular cross section should be 0.25% or higher. In case of T-shaped cross section, longitudinal reinforcement should be arranged in 0.35% or more of effective cross-sectional area of concrete. For chemical pre-stressing concrete used for factory products, it was made permissible for the upper limit of expansion rate to be 1000 into 10 to the power minus 6, which is higher than 700 into 10 to the power minus 6 rate for cast in place concrete, because control of expansion rate and of reinforcing bars, arrangement, etc. on factory products are superior compared to other cast in places. Strength. Uh, well, compressive strength of expensive concrete should be compressive strength at age of 28 days. Compressive strength of shrinkage compensating concrete shall be determined in accordance with this. Compressive strength of chemical pre-stressing should be determined in accordance with this. Compressive strength of expensive concrete shall be compressive strength at age of 28 days as for ordinary concrete. For shrinkage compensating concrete, compressive strength and strength development designated to testing similar to those for concrete with no cement replaced with expensive admixture. So compressive strength shall be obtained in same tests as those for ordinary concrete. Chemical pre-stressed concrete has higher expensivity than shrinkage compensating concrete. There are therefore cases where compressive strength obtained in accordance with method of test for compressive strength of concrete, method of making and curing concrete specimen is greatly reduced due to excessive free expansion. Thus, use condition may be much different from actual conditions. It becomes necessary to obtain compressive strength using specimens that are left in formwork up to start of compressive strength tests in accordance with method of testing compressive strength. Cements that comply with this requirement, that cement we are talking of. Cements generally used for expensive concrete are ordinary Portland cement, moderate heat Portland cement, and high early strength Portland cement, fly ash cement type B, and blast furnace slag cement type B. Generally speaking, you can say cements generally used for expensive concrete. Cements generally used for expensive concrete are ordinary Portland cement, moderate heat Portland cement, high early strength Portland cement, fly ash cement type B, and blast furnace slag cement type B. As long as these type of cements have been used, no abnormal expansion characteristics have been recognized. It has been verified that type of cement has little effect on expansivity. When using low heat Portland cement or blended cement containing 3 cementitious materials with high content of blast furnace slag or fly ash, expansion sometimes occurs early or expansivity increases as setting of concrete or development of strength varies. Cement should therefore be used only after achieving or achievement of designated decision making. Once again I read this. Cements generally used for expensive concrete are ordinary Portland cement, moderate heat Portland cement, high early strength Portland cement, fly ash cement type B, and blast furnace slag cement type B. As long as these types of cements have been used included, no abnormal expansion characteristics have been recognized. It has been verified that type of cement has little effect on expansivity. When using low heat Portland cement or blended cement containing 3 cementitious materials with high content of blast furnace slag, It has been verified that type of cement has little effect on expensivity when using low heat Portland cement or blended cement containing three cementitious materials. When using low heat Portland cement or blended cement containing three cementitious materials with high content of blast furnace slag or fly ash, expansion sometimes occurs only or expensivity increases as setting of concrete or development of strength rises. So we can say when using low heat Portland cement or blended cement containing three cementitious materials with high content of blast furnace slag or fly ash, expansion sometimes occurs early or expensivity increases as setting of concrete or development of strength varies. This cement should therefore be used only after placement, after achievement of conditions. We have here, you can say, these cement should therefore be used only after achievement of designated performance requirements is verified by conducting tests or based on records of use. Expensive admixture. Expensive admixture that complies with this used. When using other expensive admixtures than those described above, their quality shall be verified and methods of use should be fully examined. Expensive admixtures shall be stored so as to maintain quality. Expensive admixtures used for expensive concrete are divided into two major types. Expensive admixtures used for expensive concrete are divided into two major types according mainly to chemical composition, and that is calcium sulfoaluminate CSA, calcium sulfoaluminate type, and calcareous type, that is CaO type. In shrinkage compensating concrete using these types of admixtures, quantity of expensive admixtures per unit volume of concrete has conventionally been set to 30 kg per meter cube as standard. In recent years, calcium sulfoaluminate, calcareous composite expensive, admixtures and expensive admixtures with high content of calcareous components and low ratio of additives have been put to practical use, and standard quantity of expensive admixture per unit volume of concrete has been set to 20 kg per meter cube. In recent years, calcium sulfoaluminate, calcareous composite expensive admixture and expensive admixtures with high content of calcareous components and low ratio of additives have been put to practical use, and standard quantity of expensive admixture per unit volume of concrete has been set to 20 kg per meter cube. in numerous applications. It has been reported that expensive admixtures with a low ratio of additives product produced similar expensivity as in the past, even at 20 kg per meter cube. However, being established for expensive admixtures that are used at 30 kg per meter cube, amount used for conventional shrinkage compensating concrete was stipulated that quantity of expensive admixture is 20 kg per meter cube per unit volume of concrete may be used as a standard when conducting tests in accordance with for expensive admixtures with a low ratio of additives. It is also stipulated that either conventional expensive admixtures or expensive admixtures with a low ratio of additives should meet quality requirements for expensive admixtures. As other expensive admixtures then described above, expensive admixtures for mass concrete, also referred to as hydration heat control type, is also referred to as hydration heat control type for reducing cracks due to thermal stress and high early strength expensive admixtures for concrete products have been put to practical use. These admixtures are sometimes mixed with additives for controlling heat of hydration or developing strength early. Requirements for ignition loss stipulated may sometimes not be met. This is because of tests of ignition loss. Additives mentioned above are detected, while the ignition loss provides guidelines for determining weathering of expensive admixtures. Expensive admixtures should therefore be used only after verifying other quality parameters than ignition loss and verifying that quality requirements of expensive concrete are met based on existing records. Since expensive admixtures contain large amount of free calcium oxide, it can be more easily weathered compared with cement. If expensive admixture is weathered, if a expensive admixture is weathered by atmospheric moisture or carbon dioxide, its expensive property is reduced and consequently required performance of expensive concrete may not be obtained. Following points should be considered when storing expensive admixture. Expensive admixture shall generally be stored in silo having humidity-proof structure, exclusively used for expensive admixture in such a way that it shall not become mixed with cement and other materials. Bagged expensive admixture shall be stored in such a manner that shall not be in direct contact with floor, site, storeroom, and arranged in a convenient order for hauling out and inspection. Bags of expensive admixture shall be opened just before using, and admixture bags broken during storage shall not be used. If storage period is relatively long, tests shall be performed before using. Says about since expensive admixtures contain large amount of free calcium oxide, it can be more easily weathered compared with cement. Expensive admixture is weathered by atmospheric moisture or carbon dioxide. Its expensive property is reduced and consequently required performance of expensive concrete may not be obtained. That's why following points should be considered. Expensive admixture shall be stored in silo having humidity proof structure, exclusively used for expensive admixture in such a way that it shall not become mixed with cement or other materials. Bagged expensive admixture shall be stored in such a manner that shall not be in direct contact with floor, inside storeroom, and arranged in a convenient order for hauling out and inspection. Bags of expensive admixture shall be opened just before using, and admixture bags broken during storage shall not be used. If storage period is relatively long, tests shall be performed before using to confirm all required properties. Mixed proportion. When designing expensive concrete, mixed proportions, quantity of water per unit volume of concrete should be minimized while ensuring achievement of performance requirements in terms of strength, expensivity, durability, resistance to cracking, water tightness, and steel protection, and providing appropriate workability. It's extremely important to minimize quantity of water per unit volume of expensive concrete as long as designated performance requirements are met as for ordinary concrete. Quantity of expensive admixture per unit volume of concrete. Quantity of expensive admixture per unit volume of concrete. Expensive concrete should be determined through testing so as to provide designated expensivity for shrinkage compensating concrete. Quantity of expensive admixture may generally be determined based on reliable documents. Effectiveness of shrinkage compensation and chemical pre-stressing of expensive concrete in a structure is higher with larger expansion rate. However, when expansion rate is too high, compressive strength of concrete is lower compared with non-expensive concrete of same mix proportions. That's why it's important to find an appropriate range of expansion rate. Within that, strength declination does not occur. When air content and slump are constant, expansion rate of expensive concrete is mostly decided by unit expensive admixture content regardless water cement ratio and unit cement content. In order to experimentally determine unit expensive admixture content, concrete with a properly selected mix proportions and 3 different expensive admixtures content, concrete with properly selected mix proportions and 3 different expensive admixture content, testing method for strained expansion and shrinkage of expensive concrete. Basing on experimental results, unit expensive admixture content corresponding to its desired concrete expansion are to be selected. In addition, expensive admixture content for shrinkage compensating concrete and also be determined based on available data of reliable sources. Expensive admixture standard quantities per unit volume of concrete for shrinkage compensating and chemical pre-stressing concrete. Type of expensive admixtures and standards. Qualities of expensive admixtures per unit volume of concrete. There is type of expensive concrete column 1, type of expensive admixture for ordinary concrete for conventional type, and standard quality of expensive admixture. Type of expensive concrete is shrinkage compensating concrete. Other one is chemical pre-stress concrete. In shrinkage compensating concrete, expensive admixture for ordinary concrete. This is conventional type, low ratio of additives. For mass concrete, it is conventional type and low ratio of additives. Standard quantity of expensive admixture per unit volume of concrete, kilogram per meter cube, and that is ordinary concrete 30, that is conventional type, lower ratio of additives 20. Then for mass concrete, conventional type 30 kilogram per meter cube and low ratio of additive 20 kilogram per meter cube. For chemical precision concrete, for ordinary concrete 35 to 50 kilogram per cubic meter. You can say for concrete product it is 30 to 60 as well. Quantity of cement per unit volume of concrete. Standard quantity of cement per unit volume of expensive concrete should be 260 kg per meter cube or larger. Strength and rate of expansion of expensive concrete are determined by time. We'll see how to do it. That's 90% charging. You can go back in 5 minutes, come back. Meanwhile, I like to read this. You like to read this. Let's see how you can get it. Meanwhile, give me 10 minutes. Back in 10 minutes. I think it will be better for us, everyone. Meanwhile, you can see my name board. It's there. And here is Suraj_engineer@yahoo.co.uk. Suraj_engineer@yahoo.co.uk. This is my professional engineer certificate. This quality file, coordination file, this concrete, the specifications I am going to give you. Strength and rate of expansion. Strength and rate of expansion of expensive concrete are determined by quantities of cement and expensive admixture, which are components of expensive concrete per unit volume of concrete. The strength and rate of expansion of expensive concrete are determined by quantities of cement and expensive admixture, which are components of expensive concrete per unit volume of concrete. Quantity of expensive admixture required to obtain designated rate of expansion is generally determined based on assumption of a constant quantity of binders, cement and expensive admixture. Quantity of expensive admixture required to obtain designated rate of expansion is generally determined based on assumption of a constant quantity of binders per unit volume of concrete identified by replacing expensive admixture with cement in numerous cases. Increasing quantity of expensive admixture per unit volume of concrete to obtain higher rate of expansion is likely to increase ratio of unit quantity of expensive admixture to unit quantity of cement and deteriorate strength and durability of concrete. These phenomena are found in concrete with small quantity of binder per unit volume. Standard minimum quantity of cement per unit volume of concrete shall be set at 260 kg per cubic meter. Strength and rate of expansion of expensive concrete are determined by quantities of cement and expensive admixture, which are components of expensive concrete per unit volume of concrete. Quantity of expensive admixture required to obtain designated rate of expansion is generally determined based on assumption of a constant quantity of binders per unit volume of concrete identified by replacing expensive admixture with cement in numerous cases. Increasing quantity of expensive admixture per unit volume of concrete to obtain higher rate of expansion is likely to increase ratio of unit quantity of expensive admixture to unit quantity of cement. Increasing quantity of expensive admixture per unit volume of concrete to obtain higher rate of expansion is likely to increase ratio of unit quantity of expensive admixture to unit quantity of cement and deteriorate strength and durability of concrete. These phenomena are found in concrete with a small quantity of binder per unit volume. Standard minimum quantity of cement per unit volume of concrete shall be set at 260 kg per meter cube. Presentation of mixed proportion. As a general rule, mixed proportions should be presented. Representation of mixed proportion. Let us say this one. Maximum size of coarse aggregate slump, air content, water binder ratio of water, C plus F cement plus F C plus F percentage, volume of sand, that is sand aggregates percentage, unit content kilogram per meter cube, water W, cement C, admixture, that is F, expensive agent E, other admixtures F, fine aggregate S, coarse aggregate G, mm, chemical admixtures. Unit for amount of chemical admixture that should not be diluted and dissolved in milliliter per meter cube or gram per meter cube. Water cement ratio is regarded as water binder ratio, and unit quantities are presented for expensive admixture E and other admixtures F. In accordance with table, method of expression of mixed proportions of material and construction standards for mixing mixers with designated mixing capability should be used as a standard practice. Method for putting expensive admixtures into mixer and mixing time should be determined by testing so that concrete may meet designated quality requirements as a standard practice. A method and mixing time may be determined based on reliable documents or records whenever available. If mixing of expensive admixture is insufficient, although admixtures are accurately measured, and input expensive admixtures may sometimes be distributed unevenly in concrete and form masses or are provided in excessive quantities in some sections. Strength of concrete may be reduced after hardening, or expansion failure may occur locally. For mixing, therefore, mixers specified materials in construction should be used as a standard practice so that expensive admixtures or other concrete materials may be distributed fully evenly. What I say again, if mixing of expensive admixture is insufficient, all the admixtures are accurately measured and input, expensive admixtures may sometimes be distributed unevenly in concrete, which forms masses, or are provided in excessive quantities in some sections, unevenly in concrete and form masses, or are provided in excessive quantities in some sections. Strength of concrete may be reduced after hardening, or expansion failure may occur locally. For mixer specified in materials and construction standards should be used. Expensive admixtures should be mixed only after appropriate input procedure, and mixing time be determined through testing that expensive admixtures may be mixed in concrete fully evenly. Generally, expensive admixture should be charged same time with cement. Expensive admixture should be charged same time with cement. If expensive admixture is charged in mixer to mixer, either together with our other materials or separately, confirmation on whether it is thoroughly mixed or not mixed shall be carried out in advance by experiments. If expensive admixtures adhere to inner wall of mixer or mixing blades and form masses when expensive concrete is continuously mixed, mixing of masses or fragments into concrete is likely to cause local expansion failure, as in cases described above. Masses of expensive admixtures should be removed immediately after they are formed. Location and procedure of input should be reviewed to prevent masses of admixture from forming. Repeat. If expensive admixture adhere to inlet, inner wall of mixer or mixing blades and form masses when expensive concrete is continuously mixed. Mixing of masses or fragments into concrete is likely to cause local expansion failure, as in cases described above. Masses of expensive admixtures should be removed immediately after they are formed. Location and procedure of input should be reviewed to prevent masses of admixture from forming. Curing. Expensive concrete should be maintained in a moist condition all times for at least 5 days after placement. Suraj_engineer@yahoo.co.uk. In cases when steam curing or other accelerated curing methods are used, a test should be carried out to ensure in advance that required quality can be obtained through considering curing method. In cases when steam curing or other accelerated curing methods are used, a test be carried out to ensure in advance that required quality can be obtained through considering curing method. Purpose of expensive concrete is to compensate. Purpose of expensive concrete is to compensate shrinkage. Purpose of expensive concrete is to compensate shrinkage, reduce crack generation due to shrinkage, and introduce chemical pre-stress in order to improve mechanical properties of concrete structures. For expensive concrete, moist curing at early stages is very important, not only for strength development but also to obtain required expansion. Therefore, if there is a possibility of formwork being dried due to small thickness or high temperature, formwork should be sprinkled with water and maintained in a moist condition. When formworks are removed within 5 days after placing concrete, exposed surfaces should be maintained in a moist condition. Expensive concrete generally ceases expanding at an age of approximately 5 days at normal temperature. Expensive concrete shall therefore be kept constantly wet for at least 5 days after placement as a standard practice. If shoring is removed within 5 days of placement, wet concrete is required, such as spraying water on exposed surface of laying curing membrane over concrete. The special curing methods such as steam curing, insulated curing or heating are applied. It is important to confirm in advance by experiments that required properties of concrete shall be satisfied. This important paragraph, let us say, purpose of expensive concrete is to compensate shrinkage, reduce crack generation due to shrinkage and introduce chemical pre-stress in order to improve mechanical properties of concrete structure. For expensive concrete, moist curing at early stages is very important, not only for strength development but also to obtain required expansion. Therefore, if there is a possibility of formwork being dried due to small thickness or high temperature, formwork should be sprinkled with water and maintained in a moist condition. When formworks are removed within 5 days after placing concrete, exposed surfaces should be maintained in a moist condition. Expensive concrete generally ceases expanding at an age of approximately 5 days at normal temperature. Expensive concrete shall therefore be kept constantly wet for at least 5 days after placement as a standard practice. If shoring is removed within 5 days of placement, wet curing is required, such as spraying water on exposed surfaces or laying curing membrane over concrete. If special curing method such as steam curing, insulated curing or heating are applied, it is important to confirm. It's important to confirm in advance by experiments that required properties of concrete shall be satisfied. Expensive, now we're talking of inspections, and this is expensive admixture acceptance test. Conducting acceptance tests for expensive admixtures shall be responsibility of accepting party. Inspection should be conducted in accordance with this table. Expensive admixture acceptance test. Type, that is expensive admixture. Item is quality. Testing method or inspection method is verification based on test records prepared by manufacturer. Period or frequency is delivery of material. Criteria for judgment is whatever it is. Party accepting expensive admixtures party accepting expensive admixtures in acceptance tests means manufacturer of expensive admixtures. Results of inspections be confirmed by an engineer or owner. Expensive admixtures may be inspected by verifying test records prepared by manufacturer. For expensive admixtures not meeting quality criteria, such as expensive admixtures for mass concrete and high strength expensive admixtures, described decision criteria should be defined through mutual consultation. Concrete acceptance test. Conducting acceptance tests for expensive concrete be responsibility of accepting party. Inspection should be conducted in accordance with acceptance test of expensive concrete. Type, item, testing methodology or method, inspection method, period of frequency, criteria judgment. First is shrinkage compensating concrete, then chemical pre-stressing concrete. In shrinkage compensating concrete, item is expansion and strength. In expansion, testing method per inspection method, confirmation of used expensive admixture content, and in this strength testing method. Period frequency is in expansion when unloading for all batches, and for strength determined by considering importance and scale of structure, and judgment is within plus minus 3% of expensive admixture content stipulated in the specifications, and for strength it shall be made possible to estimate that probability of strength of expensive concrete decreasing below design strength is 5% or lower based on producer's risk ratio. Possible to estimate that probability of strength of expensive concrete decreasing below design strength is 5% or lower based on producer's risk ratio. Other is expansion, that is pre-stressing of within 15%. We must correspond 15% of expansion ratio. Expansion, that is when unloading once a day, it says testing method is in chemical pre-stressing concrete expansion. When unloading once a day or once every 20 to 150 meter cube, depending upon importance of structure and scale of construction, within plus minus 15% of expansion ratio as prescribed. Strength is determined by considering importance and scale of structures. Possible to estimate that probability of strength of expensive concrete decreasing below design strength 5% or lower based on production risk ratio. So result commentary, party accepting expensive concrete. Party accepting expensive concrete in acceptance test means owner or engineer. There are, however, cases in which contractors of expensive concrete conducts tests and owner confirms. In design of mixed proportions of expensive concrete, it has been verified that rate of expansion of expensive concrete is nearly proportional to quantity of expensive admixture per unit volume of concrete. Inspection of expansion for shrinkage compensating concrete can be replaced by confirming expensive admixture content in mixed proportions record when concrete is unloaded at construction site. Meaning of when unloading for all batches is that confirmation must be made if fluctuation of expensive admixture content in all mixing batches is within plus minus 3% of content stipulated in specified mix proportion. When concrete is unloaded from agitator trucks to site, for chemical pre-stressing concrete, required expansion ratio is substantially larger. For chemical pre-stressing concrete, required ratio is substantially larger, and lack of expansion also causes more negative effect on structure compared with shrinkage compensating concrete. Therefore, inspection of expansion must be carried out by expansion tests. Regarding inspection of concrete strength, tests on compressive strength should be carried out by compression test considering characteristics of expensive concrete. Other concrete inspections shall be conducted in accordance with materials and construction inspection standards. Lightweight aggregate concrete. Lightweight aggregate concrete. You know lightweight. What is lightweight? Everybody knows. It's very common. Lightweight is very common, and you know that. This chapter specifies standards on essential matters, particularly required for construction of lightweight aggregate concrete. Over 40 years have passed since lightweight aggregate concrete was first used for civil structures in Japan. Consequently, reliability and durability is gradually increasing with increase of experiences related to design and construction. At present, it is possible to handle lightweight aggregate concrete in almost same manner as normal aggregate concrete, except for items that require special attention. This talk focuses on matters not referred to in this chapter. Lightweight aggregate concrete shall be handled as if it were concrete using ordinary aggregate. It is noted that concrete with artificial lightweight aggregate is simply called lightweight aggregate concrete, and artificial lightweight aggregate also called lightweight aggregate. For construction of lightweight aggregate concrete, Manual of Design and Construction for Lightweight Aggregate Concrete and Recommendation on Design and Construction of Concrete using high strength lightweight aggregate. When constructing lightweight aggregate concrete, qualities of lightweight aggregate and of lightweight aggregate concrete shall be fully examined so as to meet designated performance requirements. Basic matters to be considered when using lightweight aggregate concrete are described. Quality of lightweight aggregate concrete. This section should be consulted during construction. Quality of lightweight aggregate. Lightweight aggregate should comply with aggregate classified. In principle, when using lightweight aggregate concrete for structures subject to freezing and thawing action, freeze-thaw resistance of concrete using that lightweight aggregate should be confirmed based on past experience and records. However, it may be sufficient to confirm freeze-thaw resistance of aggregate by referring to result of freezing and thawing test on concrete carried out in accordance with whether alkali silica reaction of lightweight aggregate occurs or not, doesn't occur, shall be verified based on use records or in concrete prism tests. You can read, we'll be back. 5 minutes. we can say because different types of lightweight aggregates are characterized by different properties. Not all types not all types of lightweight aggregates are necessarily suitable for use in civil structures. In this standard specification, lightweight aggregates made of expanded clay, pearl stone, fly ash, etc., that can be used for concrete with adequate lightweight and strength are specified. These lightweight aggregates used as fine and coarse 1 are classified in level 3 and 4 concerning compressive strength of concrete, a structural lightweight aggregate for concrete. They are generally clean, hard and properly distributed in particle size and less scattered quality because of manufacturing in factories. However, for our poor manufacturing processes and quality control will result in producing low quality aggregate and inadequate properties of concrete. Therefore, good quality products shall be selected for use of lightweight aggregate. In addition, properties of fresh and hardened lightweight aggregate concrete such as workability, strength, durability may be adversely affected because of lower strength characteristics and higher water absorption of lightweight aggregate compared with natural aggregates or normal aggregate. Therefore, it is important to acknowledge properties of lightweight aggregate. High strength and low water absorption lightweight aggregates have recently been developed. High strength and low water absorption lightweight aggregate have recently been developed by improving materials used and methods of production. High strength lightweight aggregate made by fly ash HFA is an example. These aggregates with no continuous air voids have low water absorption and high strength. Lightweight aggregate concrete using these lightweight aggregate has much better basic quality in such terms as ease of construction, strength and durability than conventional lightweight aggregate. Concrete and compares favorably with ordinary aggregate concrete. Table compares absolute dry density standards of aggregates. Absolute dry density of lightweight aggregates actually put to use varies greatly from 0.75 gram per centimeter cube to 2 gram per centimeter cube. Characteristics of lightweight aggregate also vary accordingly. For constructing lightweight aggregate concrete structures that meet performance requirements, that's why aggregates should be selected that are fit for use, and construction should be carried out considering quality of aggregate. This we shall take later on because we have to go into depth of understanding this. And meanwhile, I'll again remind about my email here, suraj_engineer@yahoo.co.uk, and it's here my certificate. This is my quality file, coalition file, concrete file, and also again I'll try to show my arbitration certificate to you to close this talk for today, because it's very serious issue, not what you think it is, but it is important that it is, and we have to be very serious in this case. It's already 2 hours 20 minutes and we can say we have to close it now. I hope you enjoyed today's talk. Thank you very much.